Okay, today we're going to talk about kites, and you'll find the information about kites in section 6.6, the second part of that section. This is lesson 50. And today we're going to learn the properties of kites. We talked about a kite before when we were talking about area formulas. So let's just review what a kite is. A kite is a quadrilateral. That means it has four sides. It has two pairs of consecutive congruent sides, but opposite sides are not congruent. So here's one pair of congruent, consecutive mean touching each other. Here's the second pair of consecutive congruent. Now, if opposite sides were congruent, this would become a rhombus. So that's why they make this statement in here, opposite sides cannot be congruent. So opposites cannot be congruent. So make sure that you're looking at a kite and not a rhombus. The properties that we're going to talk about today of kites are based on the properties of triangles. If I put the one diagonal in here, we're going to find out there's some properties. We can put that second diagonal going across this way, and there'll be some other properties that we'll figure out. And then what happens if we put both diagonals into the kite? So you are used to seeing the diagonals when you fly a kite, because those are like the braces of your kite. So think about, when I put in one diagonal, I get two triangles. When I put in another diagonal, I get two triangles. And when I put in both diagonals, I'm getting four triangles. And so we're going to use the idea of triangles to help us figure out what's going on in these kites. It says, notice that angle B and angle D are formed by congruent sides. So B is formed by the two sides with the one hash. D is formed by the two sides with the double dash. Now I want to concentrate on this diagonal, and you need to draw this illustration in your notes just like I am. This one diagonal is a shared side of two triangles now. It is congruent to itself. So you should be able to tell me something about these two triangles. They're going to be congruent to each other because of side, side, side. And so if you wanted to name those, we could call it ABD and CBD. Those two triangles are congruent. Now we're going to talk about some properties that are true because we see two congruent triangles. It says the following is true because of CP/CTC. In a kite, the angles formed by the non-congruent sides. Do you see these two are forming C and they are not congruent? These two are forming A and they are not congruent. But go back and look at the previous slide. Here, A and C are corresponding parts of two triangles. So that means that A and C have to be congruent because they are corresponding parts. If I drew that diagonal in there across here, you would understand again why they are corresponding parts, and so they're going to be congruent to each other. So we need to remember that where the non-congruent sides meet, those two angles are going to be congruent. All right, so let's try to figure out the measure of angle 1 and the measure of angle 2. We just said that 1 and the 110 degree angle are formed by the non-congruent sides. That means they are congruent, and so that's how I remember it. They're formed by the non-congruent sides, but they are congruent. So the measure of angle 1 has to be 110. You need to remember that a quadrilateral has 360 degrees in it, And so if I know 3 of the angles, I should be able to find the measure of the 4th angle. So the measure of angle 2 would be whatever 190 plus 110 plus 110 would be. I would subtract that from 360 and get 42. Now this might be the time when you want to pick up your calculator and punch in the numbers and see if you're getting the same answer I'm getting. In this situation, you need to label your picture because these did not print on your picture, I noticed. So this angle H is 132. This angle K is 60. Now this time I've changed up the problem. I'm asking you to find G and J, the angles where the non-congruent sides meet. So remember, where the non-congruent sides meet, you will find your congruent angles. So I just reminded you that they are going to be congruent. There's 360 degrees in a quadrilateral. So to find the measure of G and J, I added up 132 and 60, subtracted that from 360, and I got 168. That means there's 168 degrees left to be divided between these two angles of the kite. They are congruent, so I'm going to take that number and divide it by 2. So each of these angles would be 84 degrees. Secondly, this same diagonal does something else. This same diagonal, the one drawn from the angles formed by congruent sides, bisect the 2 original angles. Now, why are they bisecting original angle B and original angle D? Because remember, these 2 triangles are congruent by side, side, side. This angle and this one are corresponding parts that would be congruent. These are also corresponding parts that would be congruent. So CBD has to be congruent to ABD, and CDB has to be congruent to ADB. So let's see if we can work this problem. It says find the measure of the missing angles. Okay, non-congruent sides are meeting, so the angles are congruent. So very quickly, I'm going to know that angle 1 measures 110. There's that diagonal that goes between where the congruent sides meet. When I draw this diagonal in, it bisects here. So this angle that was originally a 90-degree angle gets cut into 45 degrees. So this angle right here is a 45-degree angle right here. This is now 45 degrees. So if I know that that angle is 45 degrees, I should be able to add up 45 and 110, subtracting that from 180, because this is a triangle with 180 degrees in it. So angle 2 would measure 25 degrees. Now, what about the other diagonal? This diagonal is going between the angles that were congruent to each other. It's formed when you pass from the angle formed by the non-congruent sides to the other one, or if you draw it between the congruent angles. What happens? I don't know if you can see it or not, but here's an isosceles triangle. Here is the other isosceles triangle. This original angle B is the vertex angle of this new isosceles. This original angle D down here is the vertex angle of the other isosceles triangles. Now these are not congruent to each other, obviously, but they are each isosceles. So we know that the triangle ABC and the triangle ADC are isosceles, and that's going to help us. Remember that base angles are congruent. So right here, those two angles and these here are going to be congruent to each other. Now, at first glance, if you're not careful, you might think this is a rhombus because it's kind of a squatty kite. We think about a kite having a longer lower body, but this is not a rhombus, it is a kite, because one pair of adjacent congruent sides, second pair of adjacent congruent sides, and opposite sides are not congruent. So we just drew in this diagonal that goes from between the non-congruent sides. We just drew in this diagonal. That means that I just formed two isosceles triangles. Can you see that? If you can see the two isosceles triangles, you'll be in good shape. So I'm going to try to find this angle 1. The vertex is 90, and I'm trying to find one of the base angles. So I want to find the measure of the numbered angles. Angle 1 is a base angle with a vertex of 90. So I'm going to take the vertex angle of 180 and subtract 90 from it and divide that by 2, because out of the 90 degrees that are left, it has to be equally distributed between these two angles. So the measure of angle 1 would have to equal, what would it have to equal? It would have to equal 45, right? And then the measure of angle 2 is in a different situation. This is the vertex angle this time. Angle 2 is the vertex angle with two bases equaling 53. Well, the two bases, if I add those up, would be 106. So that means the measure of angle 2 would have to be 74. So this vertex angle would be 74 with the bases each being 53. So I put the angles in different positions. This was the base angle you were looking for. This was the vertex angle that you were looking for. All right, there is only one theorem that has to do with kites. Every other property of kites is based on the triangles formed by the diagonals. But here's the one theorem about kites. Kites, diagonals will be perpendicular. If a four-sided shape is a kite, yes, this is a kite, then the diagonals will be perpendicular. Now that's what we said about rhombuses and squares also. But here's the difference. A kite is not a parallelogram, but it is a quadrilateral that has perpendicular diagonals. So FH is going to be perpendicular to JG. And here's something else that I noticed. When I draw in both of the diagonals, I am really getting two sets of congruent right triangles. Because remember, there's right angles here, correct? So these two are going to be congruent because of hypotenuse leg, hypotenuse leg. Same thing here. We have two sets of right triangles that are congruent by hypotenuse leg. So if I could solve this right triangle here on the upper left, I would know everything I needed to know about the lower left, because there would be corresponding parts that are congruent. Same thing, if I could solve this triangle, I would know every part of this lower right triangle. So understanding kites is really all about triangles. It says find the measure of the numbered angles. All right, here's angle 1. I think you're going to know what that is because here's the diagonals and they are what? Perpendicular. So remember, in a kite, the diagonals are perpendicular and I'm going to get 4 right angles. So the measure of angle 1 has to be 90. Now you got to remember that right here, even though angle 1 was 90, so is this angle 90. So there's our right triangle. So if we're trying to find the measure of angle 2, we remember that the sum of the 3 angles is 180. So angle 2 would be 180 minus 90 plus 67, and that would leave us with 23. And then lastly, if I am trying to find the measure of the angles here in this triangle, it's a little bit different. I'm going to remember that this is 90. So I'm going to find the measure of angle 1 first. The measure of angle 1 would be 180 minus 90 plus 18, which would be 72. And this goes back to what I just said. This triangle and this triangle are congruent. So I'm looking at corresponding parts here. So the measure of 1 and 2 would have to be the same because they are corresponding parts or corresponding angles. So the measure of angle 2 would be 72. I know this has been a lengthy video, but we have to go through all of the properties of kites. So now I need you to watch the explanation for reteaching 6-6 on kites. If you're not watching the video, it's very obvious when you turn your work in, so I would tell you to watch the videos because I'm grading on correctness of your reteaching.